All right, today we're doing day 13 from chapter 4. It's all about area problems. You guys good to go on your notes?
Yes.
All right, awesome. So here's example 1, 1A. It says, find the area of the shaded region. So in your notes, you have the same picture, but it's not labeled, so I'll give you a second to label it. All right, so if you're looking at this, we have a big rectangle, right? It's 8 by 10. Then we have a little rectangle that's inside. It looks like it's 3 units from each of the edges. Yes?
Might we subtract 3 from both the sides to get that?
Subtract 3?
So do 10 minus 3 and 8 minus 3 to get the...
Okay, so if we do 10 minus 3, that would give us from here to all the way over here.
6.
Yeah, there's actually 6 total that needs to be taken away from this dimension of 10, right? Because you have 3 here and 3 here. Yep. And then what about the 8? What would we subtract from the 8? Yeah, 3 and 3 again. Very good. So 10, take away the 3 units over here, the 3 units over here. This littler rectangle has a length of 4. And then 8, take away the 3, take away the 3. That's 6, right? And 8 minus 6 is 2. Do you guys remember how to find area?
length times width.
Length times width. Good. And I don't get too hung up on which one's which. One way's length, one way's width. So just call one and one the other. So for that inside rectangle, that's the one we're trying to find the area for. So the dimensions are 4 and 2. So it's the area of this little guy. 8. Good. What are your questions?
When there's no label on the quiz, we should put 8 units.
Yep. Yeah. So the question was, when there's no label, so like feet, inches, centimeters, just put units. And whenever we're talking about area, it's square units, written units squared. Okay. So just unit and then a little 2. What are your questions so far? All right. Part B. So same setup, right? Except now which one's the shade? It's kind of like flip-flops, right? So now the shaded region, it's kind of like I don't know, I want to say like an inner tube, but it's not. It's like a rectangle, right? Like a rug. Kind of looks like a rug, right? So we want to find the shaded region. Balcony.
Yeah, like...
I don't know what it is. I'm going to go with a rug. We're looking at a rug here. You got a white rectangle inside of a cream-looking rectangle. And I want to know how much cream there is. Cream-colored. Brownish. Okay.
It looks like meringue.
Whatever. This is what we're looking at. Everybody deal with it. What should I do? Yes. Okay, so we need to find the dimensions of the little guy. So yes, we can take 10 minus 6, we get 4. Same thing, 8 minus 6, we get 2. Here's how I'm going to find the shaded region, okay? So on the last one, the shaded region was just a rectangle. We know how to find the area of a rectangle, we just went for it, all right? Here we're going to do it a little bit differently because we don't even know what to call this shape. We definitely don't have a formula to find the area of it. So we can find the area of the shaded region by finding the area of the whole thing and then subtracting the part on the inside that's not shaded. So that's going to be our plan of attack here. So how would I find the area of the whole thing?
8 times 10.
8 times 10. How would I find the area of the unshaded? Well, that's what we just did on the last one, right? The inside, the 2 and the 4. Okay? What's 8 times 10?
80.
What's 4 times 2?
8.
8. What's the area of the shaded region?
72.
Very good. Any questions? So this says a rectangle is 3 times as long as it is wide if the length is increased by 6 meters and the width by 8 meters. The area is increased by 108 square meters. Find the original dimensions. So read through that a couple times. Start thinking of a strategy. I'll give you a few minutes. A rectangle is 3 times as long as it is wide. All right, so I'm going to start by trying to visualize what I'm looking at. 3 times as long as it is wide. So we could call one dimension the width, right? And then what would the other one be called? But what would we call it? We don't want 2 variables. So if one's W, what's the other one? 3W. It's 3 times as long as the width. So this guy's W, this guy's 3W. Now we're going to make an even bigger rectangle. And in the bigger rectangle, we're going to increase the length by 6. And this one's the length. The length was 3 times the width. So what will the length be in my new big rectangle?
3W plus 6.
3W plus 6. Very good. And I'm going to increase the width by 8 meters. So what would I call the new width?
11.
W plus 8.
Oh, wait. I was thinking 3.
Now, they're saying that the area of this guy, the bigger one, is going to be 108 square meters larger than the area of this one. So let's write an equation. So if I start with the original and I add 108, that should give me the area of the new. Everybody still with me? How would I find the area of the original? 3W times W. Good. How would I find the area of the new?
3W plus 6 times 3W plus 8 times W plus 8.
Very good. Very good. So, to find the area of the original, you'd multiply these two. I still need the plus 108. To find the area over here, I'd multiply these two. So this is the equation that I need to solve. Then I'm going to need to plug it back in to find the dimensions of the original rectangle. What are your questions? All right, so let's tackle this guy. What should I do? Yes.
Double distribute.
Yes. Well, we got to just multiply in the front, right? What's 3W times W?
4W.
What?
Or 3W.
3W squared. Very good. All right, and then you're correct. In the back, I need to double distribute. So I'm going to go 3W times W, 3W times 8, 6 times W, 6 times 8, plus signs in the middle of all those. So your next step looks like this. Everybody still with me? I didn't mean to put you on the spot. Okay, and magically, what's going to happen? I don't think it happens yet. First, we need to do what? Combine like terms. So I see a W and a W. How many W's am I going to have? 30 W. Now the magic. What happens when you try to get the W squareds together? They disappear. You have 0 W squared. So get rid of them. Similar. Okay, now what?
I thought about crispy and smacking you just now.
Subtract 48.
Subtract 48 from both sides. Shh, getting a little rowdy over there. What's 108 minus 48? 60 equals 30W. Then what? Divide everything by 30, and we get W equals 2. Now, is that the answer? No, that's just the width. What do I also need? Yeah, the length. And the length is 3 times as long as the width. So 6, 3 times 2. Good. Now, length and width are not square units. Okay? Length and width are just meters and meters. When you multiply them, that's when you have to put the squared after it. Okay? What are your questions? Example 3 says an oil painting is 10 inches longer than it is wide and is bordered on all sides by a 3-inch wide frame. In the area of the frame alone is 402 square inches. What are the dimensions of the painting? Oh my goodness. I have to read this one like 4 times. An oil painting is 10 inches longer than it is wide. Okay, so if we have the width, the length would be W plus 10, okay? Right now I'm just thinking out loud, trying to get some ideas. Its border on all sides is 3 inches.
So then that would be a frame that's 3 inches on all sides.
Okay, so you have like 3, 3, 3, and 3 on all sides. Okay? The area of the frame. Okay, then okay. All right, I think I have a plan. Let's draw a picture.
Yeah.
So I have my rectangle, right? We already talked about we have the width. The length is 10 inches longer, so width plus 10. Then I have the frame, right? Boom, frame. We got 3, 3, 3, and 3. Where'd that 6 come from?
It's the 3 inches on.
Oh, 3 and 3. Yes. So if I am writing expressions for the new width, right, the width of the frame, it's the original width that I call W plus the 3 that's here plus the 3 that's here, so plus 6. Good. What would I call the length now? W plus 10.
Plus 16.
Well, yeah, you could do W plus 16 or W plus 10 plus 3 plus 3. Yep. So if you combine the like terms, you have the 10, the 3, and the 3, you get W plus 16. Okay. What do I know the area of right now?
The frame.
I know the area of the frame. So that's like this beigey colored thing, right?
Is that like just the frame, like subtracted by the painting?
Yes. So how would you find this area? Yes, Josh.
So you find the area of the painting and then subtract that from the frame.
Yeah, so if we know the whole area and we take the area of the painting away, that should give us the 402. That's the frame, right? Is that the plan of attack here? Okay. So painting plus the frame equals the whole thing. Right? You take this guy, you add this guy, you get the whole thing. Do I know the area of the painting?
No.
Kinda. What could I call the area of the painting?
W squared plus 10W.
Yeah, W squared plus 10W is what it'll end up being. But yes, we would write it as W times W plus 10 plus the area of the frame. I already know that one. 402. And then that should give me the whole area. Now, originally, we were saying that you could do the area of the whole thing minus the area of the frame and make it equal to the area of the inside. That's the same thing, okay? It's just, you just like subtract this from over here. So, a lot of variations of this same equation that are going to work. Does that make sense? It's like you could have the minus 402 on the other side, you know what I mean? Bueller, yes? Everyone awake? Friday? Supposed to be bouncing off the walls, no?
It's not 7th hour.
Oh, okay. No, that happens during 7th hour. Great. All right, so here's what I'm working with. What to do. Yes, sir.
Multiply W to W plus 10 and then W distribute.
Yes, so I'm going to multiply W times W times 10 up front. Back here, I'm going to do W times W plus W times 16 plus 6 times W plus 6 times 16. All right, and here it is, magically ready, boom. All right, I have some like terms I can take care of. Right here, W's. So in the same step, where did the W squareds go? They went away. When you try to get them together, when you subtract W squared from both sides, you get 0 W squared, so you don't need to write those anymore. They're gone. Now, collect your W's. How can I do that? Yes, sir.
Subtract 10W.
Subtract 10W from both sides. All right, so I end up here. 402 equals 12W plus 96. Then what? Subtract the 96 from both sides. We end up with 306 equals 12W. And finally, divide by 12. What's W going to equal? 25 and a half, or 25.5. Is that the answer?
No.
What do I do? Yeah, I want the dimension, so that's the width and the length. This is only the width. And somebody said it, the length is just, we call it W plus 10. So add 10, and here are your dimensions. So 25 and a half inches by 35 and a half inches. You guys know I'm not a big decimal fan. I probably would have wrote that as a fraction. This is, again, one of those times where maybe improper fraction isn't as useful as I'd like it to be. I prefer improper fractions, but when you're talking about real things, it's not something you would usually use. You wouldn't say like 51 halves inches, you know what I mean? All right, any questions? Example 4 says a rectangle is twice as long as it is wide. If its length is decreased by 4 feet and its width is decreased by 2 feet, its area is decreased by 24 square feet. Find the original dimensions. Oh my goodness. All right, read it a couple times. Start to pull some information out. I've got a rectangle. Looks like I got 2 rectangles, right? Twice as long as it is wide. What does that mean? Anyone else want to talk today? I don't know. Any ideas you have? Okay, draw a square.
Oh, right.
Oh, a rectangle. Okay, good.
And then label it.
How?
W as the width.
Okay.
Length is 2W.
Okay, so we have a W and we have a 2W because of this word twice. Twice as long as it is wide. So if this is W, this is 2W. We're going to decrease the length by 4. What does that mean? Minus 4 from where? Okay, so our new length is 2W minus 4. We want to decrease the width by 2 feet. W minus 2. And that's going to decrease the total area by 24 square feet. All right, what are some ideas? Anyone but those two. Now there's only 2 people talking. All right, roll with it.
Let's see. 2W times W minus or plus 24. No. Sorry. 2W minus 4 times W minus 2 equals 2W times W minus 24.
Okay, so you want to do this area, the larger area. You want to decrease it by 24 and make it equal to this area. How do the rest of you feel about this? So the way I would do it, so if its length is decreased by, and its width is, so here's kind of where you want to start. So its area, so this guy's area is, hold on, no, we're talking about the original guy, right? A rectangle is twice as long as it is wide. If its length is decreased by 4 feet and its length is decreased by, okay, so we're back to talking about the original. Its area, so the original one's area is where your equal sign goes. Decreased by 24, okay? So this area is decreased by 24. All right? So which one's smaller? This one. So which one needs the minus 24 with it? This one. Yep. So the original, I think I said it backwards up here. I was trying to make it make sense to you, and I ended up confusing myself. Whoa! Talk about mind-blowing on a Friday. Okay, so when you're stuck, like I just clearly got myself stuck. Did anybody hear that? You guys stopped listening like 10 minutes ago. When you get stuck, think about which one's bigger, okay? You want to start with the bigger one and take away the 24. That'll give you the smaller one. That's the easier way to think it. I was trying to use the word is kind of as our marker of where to put each area. I ended up getting myself all screwed up. So anyway, the larger one, the original, take away the 24 is going to be the new one. Are we good? Yes. You're just agreeing so I stop talking, aren't you? All right, so the original area, we multiply the 2W and the W. We're going to take away the 24. That'll give us the new area. All right, are we good? What do I do? Yeah, we want to multiply up front. 2W times W. 2W squared. You'll have minus 24 equals. And then back here, what's the process called? Double distribute. Very good. So 2W times W. And then you want to do, whoops, sorry, my bracelet is advancing the slides. So 2W times W is 2W squared. 2w times 2 is minus 4w. Negative 4 times w is minus 4w. And negative 4 times negative 2 is plus 8. All right. What's going to happen to the w squareds? They're going to disappear. When you subtract 2w squared from both sides, you get 0w squared. Over here, what's negative 4w minus 4w? Negative 8w. So I'm going to do that all in one step. Ready, boom. Then what? Subtract 8 from both sides. You get negative 32 equals negative 8w. And then what? Divide both sides by negative 8. What's w equal? 4. What was the original question? Find the original dimensions. So we called one of them w. We called the other one 2w. So what's the length?
8 feet.
8, right? Because you just multiplied by 2. So the dimensions are 4 feet by 8 feet. What are your questions? Of course. Whoa, we're not done. We need to summarize. What did we talk about today? What's the overall idea? Area. You can write area word problems if you want. You can just write area. Boom. If you are still struggling with something, besides what the heck is she trying to talk about where this equal sign goes for so long, write it there. We'll talk about it on Monday, okay? And then think of a sample test question that you could relate back to this area. I'm going to pass out your homework. You have the rest of the hour to work on it. Try to get it done. Nobody wants weekend homework. Just try to power through. And we'll go over it on Monday.